Good afternoon and welcome to our third training session for the Maritime Peplink Certified Engineer. We'll be getting started in a minute or so here. There's still a few more people joining us. So today we're going to cover the third section, which is optimizing the equipment to get the best out of the equipment for your clients. So we've already covered selecting the equipment and installing the equipment in the first two sessions. If you haven't seen the first two sessions, you should have received links for them in the emails. Otherwise, they are on the forums there, so you can go and watch them. So today we have three areas that we need to look at. We've already evaluated the equipment and installed in our previous webinars. So the first thing to consider, SpeedFusion. What is it? How does it work? And how will it benefit our setup? Second, the virtual systems like Fusion Hub and the SpeedFusion endpoints, and also Fusion Sim for remote sim management. The third thing we will look at is our cloud-based monitoring, whether that is our SD-WAN controller or InControl 2. Our white paper on SpeedFusion and best practices is available on our forum. Please also have a look at the technology section of our website. This covers many different technologies we have developed. Any links that are appearing on the slides, we will put them in the question and answers topic that we put on the forum afterwards as well. So if you don't get the links off the slides, don't worry, they will be there for you to access. So let's have a look at some of the SpeedFusion's basics. SpeedFusion is a point-to-point protocol which operates between two SpeedFusion-enabled devices. This could be between two routers or between a router and a Fusion Hub. There are two key functions of SpeedFusion. One, bandwidth aggregation, which we commonly refer to as bonding, and it increases the reliability due to the use of multiple WANs. This creates a resilient VPN which can operate on many different types of WANs. Our algorithms are able to detect failures and seamlessly redirect traffic at a packet level. This is a typical deployment of SpeedFusion, and it consists of the router installed on board the yacht, which then connects via SpeedFusion to a router on a high-speed internet connection. This could be an office or at a data center. In this example, we have an MBX on board and an EPX at the other end. An alternative deployment is to use Fusion Hub. Fusion Hub is a virtual appliance which can run on Amazon Web Service, Azure, Citrix, DigitalOcean, Google Cloud, Microsoft Hyper-V, VirtualBox, VMware, and Voltra. We've recently introduced a third method of using SpeedFusion. The SpeedFusion Cloud allows you to utilize SpeedFusion without setting up your own endpoint. The benefit of this is you don't have to set up your own Fusion Hub in a data center and configure it. We're currently offering 100 gigabytes free. After that, there are packages available. The full guide on how to set up this is on the forum, and this also includes the pricing for the packages. Travis did a webinar about the SpeedFusion Cloud. The link will also be posted on the forum there as well. So SpeedFusion uses a Diffie-Hellman key exchange to create a secure WAN-to-WAN link at 256 AES. Each WAN has its own set of keys, so it is independently encrypted. Let's say it's a SpeedFusion tunnel between a router with 3 WANs and another router with 4 WANs. This tunnel would have a total of 12 separate encryption keys. So these are some of the main features of SpeedFusion. So bandwidth bonding is combining all your available links into one single reliable connection. This is great for when a vessel is at sea and constantly moving through different cellular environments with changing coverage, different providers, and varying throughput. WAN smoothing creates duplicate packets on the different WANs. This means if a single WAN fails, the missing data does not need to be re-requested. This is great for real-time applications like VoIP and online gaming. Hot failover allows you to utilize a single WAN or multiple WANs and fail over to a secondary WAN only when the primary WANs have failed. This is great if you have a single unlimited data package, because when you can use additional data metered packages as backups. So PepVPN is a single WAN VPN. This can connect on a backup WAN if the primary WAN fails. So the first one we're going to look at is the first level, and that's PepVPN. So this is a single WAN VPN and can fail over to the second WAN or third and fourth WAN. They can all be set in priorities. The failover is not a hot failover. So this means that the VPN disconnects from the first WAN and then re-establishes on the second WAN. So first question of the day. SpeedFusion VPN from a yacht can enable the streaming of IPTV from the home country to a remote vessel. Is this statement A, true, or B, false? So the answer is A, true. You can access geo-block services using SpeedFusion. So our second level is hot failover. Hot failover works by establishing a multi-WAN VPN, but utilizing a single WAN. If that WAN fails, other available WANs are immediately utilized without the VPN disconnecting. This means that services such as VoIP and IPTV keep on working across different WANs. When the original primary WAN is available and healthy, the VPN tunnel is flawlessly moved back to that WAN. So the third version of SpeedFusion is WAN smoothing. WAN smoothing works by duplicating packets and sending them over multiple WANs. This creates a much more reliable connection for two-way services like VoIP and video conferencing. This improves the quality of experience. So we also have another technology called forward error connection. So what's the difference between WAN smoothing and forward error connection, and when should you use each one? So the WAN smoothing is sending duplicate packets. You can choose the intensity of duplication from normal to maximum. WAN smoothing is best for two-way real-time applications such as VoIP and video conferencing. Another technology that we've developed with SpeedFusion is the forward error correction. This works by creating reserved packets. If packets are lost, the reserved packets are used to extrapolate the lost data. Forward error correction is best for one-way streaming applications. Okay, time for another question. SpeedFusion WAN smoothing technology can improve the user experience in which of the following scenarios? Is it A, Google Maps, B, Spotify, C, Google Meet video conferencing, or D, next video VoIP phone? So the answer is C and D. So most people have got that one right. So someone's asking why not B? So Spotify is a one-way streaming service, not a two-way streaming service. So it will work with it, but it's not really going to improve the service very much. So the fourth level is speed fusion bonding. This is where you bond all the available connections into one single fast and reliable connection. With bonding, you want to bond multiple connections of similar characteristics, like multiple cellular connections. You don't want to bond connections with different characteristics, like satellite and cellular together. The difference in latency and throughput means that the bonding will create a very poor experience. Okay, so how does bandwidth bonding work? Firstly, data is created on the LAN. For this example, we're going to use an IP CCTV camera, which is communicating with a DVR at the other end of the speed fusion tunnel. Once that data arrives at the router on the site, the outbound policies dictate where that traffic will be sent. For this example, we could use the enforced rule with the destination address set to the IP address of the DVR and the source address set to the IPTV camera's local IP address. The camera traffic would then be routed over the speed fusion tunnel. Other traffic could be directed to break out onto the internet locally. Next, the traffic directed to the speed fusion tunnel will be encrypted with 256 AES encryption and distributed across the available WANs in the speed fusion tunnel. This will then pass over the internet. At the other end of the speed fusion tunnel, the data is decrypted and the packets are put back in the original order. Finally, the traffic arrives at its final destination. In this case, the DVR or the person viewing the camera feed at the other end. So using speed fusion does create some overhead. Let's have a look at this. So if each speed fusion packet has a fixed number of bytes at 80 bytes, this means that larger packets are much more efficient at transferring data. The average overhead is around 19%. This is explained a lot more in depth in the speed fusion best practice guide. So in comparison to IPsec, we have an additional 4.4% overhead, but we gain all the benefits of speed fusion. This is a very acceptable trade-off. So let's have a look at this setup. If you have two 10 megabyte per second download and 2 megabytes per second upload internet connections, using speed fusion bonding, will it result in a speed fusion throughput of 20 megabits per second download and 4 megabits per second upload? Is this true or false? And yes, I can see true is also spelled incorrectly there as well. Okay, so the answer is B, false. So assuming we have an average overhead of 19%, we need to subtract the 90% overhead from the final result. Ultimately, you should end up with about 16 megabytes per second download and 3 megabytes per second upload. So speed fusion traffic steering is now possible. This is achieved by creating subtunnels within each speed fusion tunnel. Each subtunnel can have different settings for each WAN. So each WAN can have different priorities, bandwidth limits, and as well as enabling speed fusion WAN smoothing and forward error connection on the different subtunnels. So you can configure up to 5 subtunnels per VPN. Okay, so bonding and cellular and satellite, why do they not work together? So when you have high difference in latency between the links, TCP protocols have issues with retransmitting lost packets, which has a drastic effect on both throughput and latency of the tunnel. When using satellite links, we recommend they are used as a failover link. So what factors affect the bandwidth available on your cellular or satellite connections? Many factors come into play. The three main ones are common between cellular and satellite, but react and behave in very different ways. So signal strength. With satellite connection, your coverage area is going to be much larger than cellular, and the signal strength will also be more consistent even when moved around. Cellular signal strength is going to be vary massively depending on your location and also the network availability. And the backhaul can also be a limiting factor. You might get a great connection to the nearest cell tower, but that tower could have limited bandwidth available on its backhaul. Generally, with satellite connections, backhaul is not an issue. So contention ratios. With satellite connections, you get CIRs and MIRs, which dictate the minimum guaranteed throughputs and maximum potential available bandwidth. This is not the case with cellular. Cellular is a free-for-all with no guaranteed throughput. Okay, so what are the benefits of using multiple cellular modems? So let's say 3 users are connected to a tower and the tower's got 100 megabits per second of capacity. Assuming the tower divides the capacity evenly, each user will get 33 megabits per second. Now let's say one of these users is using a multi-cellular router and is able to create 2 connections to the same tower. That single user will now be able to get half of the available capacity. Ultimately, you want each of your modems to be using different networks for the best results. Okay, so time for another question. Which of the following features are designed to increase network resilience? Is it A, drop-in mode and LAN bypass, B, time-based configuration, C, per user bandwidth control, or D, high availability via VRRP? Okay, so the answer is A and D. So time-based configuration is used for network management and per user bandwidth control is used for traffic management. Okay, so some useful features for maritime applications are SIM card USSD support. Using USSD code, you're able to check your balances, activate data packages, and configure carrier settings. This depends on the network you're using and if they support this. We also have time-based configuration, which can be figured using the schedule feature. Functions that can be tied into schedules include WAN connections, outbound policies, PoE, SSIDs, and firewall rules. Content blocking allows you to set up rules via domains and applications. User groups or subnets can also be excluded from these rules. Per user bandwidth limitations can be implemented, limiting individual users within a group to a max speed. This stops one user hogging all the bandwidth. So data pooling can be defined for multiple SIM cards and in Control 2. Limits can be set and notifications sent out at predefined levels. Roaming country selection allows you to deny or allow certain countries using the mPCE. This helps control costs and avoid shock invoices. Our enterprise features can be studied on our website. Also, searching for these features on our forum will reveal a lot of info about the different applications of these features. So lots of new features have been introduced with firmware 8.0.1. This includes deep packet inspection, application filtering on the PEP VPN, fast roaming support with the AP controller, country-based firewalls and outbound policy, and also scheduled SIM switching. So with scheduled SIM switching, you can set it so that SIM A is used for half the month and SIM B is used for the second half of the month, things like that. So there's quite a lot of flexibility there. Firmware 8.1.0 went into beta last week. You can read about the latest features in the release notes. There are some really cool advancements, including NetFlow support. This has been asked for by quite a few people. So go and check it out. It's up on the forum now. So more info on firmware 8.0.1 is available on the webinar covering it, and also on our website. We've got a website dedicated to it. Again, both of these links will be put in the frequently asked questions on the forum. Okay, question time. Which of the following load balancing algorithms are most useful for maritime deployments? You can choose more than one answer. Okay, so the answer is A, B, and D. Obviously, all of these algorithms can be used for any application, and you've just got to find out which ones work best for you. But in my experience, these are the three that are most used in maritime. Okay, so we're going to have a look at them in a bit more depth now. So weighted balance allows you to assign traffic to different links and ratios based on sessions. So this works great for load balancing and sharing traffic between multiple links. For cellular, we recommend that you set each WAN at the same ratio because vessels are moving around and the cellular connection speeds are always changing. If you had a connection with, say, fixed speeds, and one of them is 10 megabytes per second download and 20 megabytes per second download on the second link, what would you set the weighted balance ratio at? Well, you could set it at 1 to 2, 2 to 4, 3 to 6, 4 to 8, or even 5 to 10. All of these weights will give the same result. So weighted balance does not apply to the SpeedFusion profiles that you've set. Weighted balance also cannot be used to direct traffic to a SpeedFusion tunnel. So the next outbound policy is priority. Simply put, this routes all the specified traffic across the preferred connection as long as it is healthy. When the connection is no longer healthy or not available, traffic is routed over the next available connection. This rule can be used to direct traffic to SpeedFusion tunnels. And the next rule is enforced. So enforced means that the specific traffic will only be able to route over that single defined connection. Enforced can be used to direct traffic to a SpeedFusion tunnel. We'll be doing a webinar in about a month, which will cover setting up of these rules and actually configuring them on the devices. This will be a live demo and explanation of real-world situations. Okay, so now we've covered SpeedFusion. Let's have a look at some of our virtualization solutions. So Fusion SIM is Peplink's proprietary remote SIM management solution. So firstly, the remote device requires an internet connection to connect to the internet. This is usually from a SIM physically placed in the router in the traditional way. Secondly, the router connects to the Fusion SIM cloud. Think of the Fusion SIM cloud as a bit like in Control 2. It is there to monitor and manage all the dispersed devices from a central location in the cloud. The Fusion SIM Cloud will allocate SIM cards depending on your set criteria. These could be geo-based or data package-based, or a combination. Next, you can choose to use SpeedFusion bonding or just break out locally onto the internet. Finally, as the router moves into a different location, Fusion SIM Cloud can automatically assign a different SIM card which is better suited for that area. And it doesn't necessarily need to be a different country, it can just be a different region within the same country. If you know a provider works better in certain regions, you can define those as well. So these are all the models which currently support Fusion SIM. So all of the HD domes, all of the MBXs, SpeedFusion Engine and UBR models, they all support Fusion SIM from day one. So the HD2 Mini supports Fusion SIM from the upcoming hardware revision, and the HD2 IP67 supports it from the most recent hardware revision. Our Flex modules for the EPX and SDX will soon support Fusion SIM too. Okay, let's have another question. If a user would like to utilize the Fusion SIM function, which of the following models would you suggest? The UBR Rugged, Transit Cat18, HD1 Dome, or HD2 MBX? Okay, so the answer is A and D. The HD1 Dome only supports local SIM injection, as it is unable to maintain an internet connection to the Fusion SIM Cloud while obtaining a remote SIM card. So you can use the SIM bank to locally inject it, but not over the internet. So the other virtualized product we're going to have a brief look at is Fusion Hub. So Fusion Hub is our virtual appliance which can run in the cloud. This is a rapidly deployable and scalable product. Please have a look on our forum for the latest installation guide. Installation in the cloud can be achieved in under 5 minutes. Trial versions are available from your InControl 2 account under the warranties and license section. So InControl 2 is our powerful cloud-based monitoring platform. So we're not going to go into this too much today, as InControl 2 alone will require a series of webinars. One of the most powerful features of InControl is the remote access feature. This allows you to easily log into the device as though you were there. Okay, so I'm going to cover some of the frequently asked questions from the first and second session. So these are all posted up on the forum. I'll just go through them now because they did seem to be asked again and again there. So can you link multiple domes to one SIM injector? Yes, one SIM injector can support up to 8 devices. So are the modems replaceable in the HD1 dome? No, they're not replaceable. We do provide like upgraded models with the latest modems in them, but we don't upgrade the modems as such. So is the dome powered by PoE? Yes, it is only powered by PoE. The only power input is PoE on the domes. Is it okay to paint the domes and the antennas? Yes, you can paint them as long as it's non-metallic paint. It's best if it's spray painted on, so it's nice, thin even coats as well. And does the HD1 and 2 dome work without the SIM injector? Yes, they do. You can physically put SIM cards inside them. Okay, so then the MBX. So is the MBX and the HD2 and the HD4 MBX the same chassis? And can you interchange the flex trays? So yes, they are the same chassis, but no, you can't interchange the flex trays. So if you buy an HD2 MBX, it's always going to be an HD2 MBX. You can't upgrade that to an HD4 just by changing the flex trays. There's some more questions from session 2 about the dome and the SIM injector. So do you need multiple Ethernet cables? No, it's a single network cable between the dome and the SIM injector. And then from the SIM injector, you can connect to the network. Can the dome be used without the SIM injector? Yes, you can put physical SIM cards on it. So yeah, the question about which Peplink model is compatible, we just covered that. So are our antennas and domes 5G ready? So the domes are not 5G currently. And well, the current ones that are out there aren't 5G ready because they've only got the fixed modems in them. So our antennas are 5G ready, so they cover all the frequencies for that. Guys, if you've got any questions from today's session, if you can put that in the question and answers function in Zoom, that'd be great, and I'll get around to answer them in a second. So what is the recommended distance between the dome and the SIM injector? There's no minimum distance, but the maximum distance is 150 meters. So do you need, when you use the SIM injector, do you need a second cable for the LAN or the dome, etc.? No, it's a single cable between the dome and the SIM injector, and then a second cable to connect the network to the SIM injector. So is it possible to have dislocated SIM injector from the dome over the internet and have it connected to the SpeedFusion? So yes, this is possible to the HD2 dome, but not the HD1 dome, as we just covered that before. Okay, so any questions from today? I've got a few here now that I'll go through. Okay, so Simon asks, with bandwidth bonding, are there issues bonding two different LTE services together? I'm thinking the HD2 dome with one Cat6 and one Category 12 modem. No, there's no issues, and this kind of goes in with the next question as well. There's no issues bonding the different ones together. There's settings within SpeedFusion that detects the real-time throughput and packet loss and things like that. So you can bond different versions together, no problem. So I'll cover a little bit more of that in the next question as well. So the next question is from Chris. How can you best configure SpeedFusion to automatically deal with the massive variability of cellular performance over different connections? Is it common to have one connection be slow and high latency and others fast and low latency, depending on location or even time of the day? Yeah, so this is how it's all built into SpeedFusion with the latencies and packet loss and things like that. And the SpeedFusion is automatically calculating how much throughput can be put through different WANs. So if you see that one WAN has got a lot more data going through it than another WAN, it's because it's capable of carrying it and the other WANs aren't at that particular time. And there's a lot of settings on the advanced settings of SpeedFusion that you can have a look at as well, like there's a latency cutoff and things like that. That allows you to fine tune things a bit more as well. Another question from Chris. The Puma seems to lack the 600 megahertz band 71 frequency. This is very important in the USA. So what are our recommendations for band 71? Okay, so there will be a new spec sheet for the Puma in the near future because that is undergoing a bit of a redesign there on the lower frequencies. So it will support that. And that will be posted on the forum once that is available in that configuration. So Ivan asks, bandwidth bonding can only be used for WAN traffic or only for SpeedFusion VPN? I'm not exactly sure what you mean there, but with SpeedFusion, you can set up a SpeedFusion tunnel and you can use it for just some traffic, like the stuff that you only want to go to the data center, and then the general web browser and stuff like that can break out onto the internet locally. So you're very flexible in how you configure it and what traffic goes over it. I'm not exactly sure what you're asking there. If you want to rephrase it, you can. So David's asking about bonding 4G and 5G. So the thing with bonding 4G and satellite is the latency difference is absolutely massive. We're talking about like say 80 milliseconds up to like 600, 800 milliseconds is the difference. So there's a massive difference there. Whereas the difference between 4G and 5G is going to be maybe 60 milliseconds latency. Which currently, that kind of difference happens currently with 4G bonding even, with different networks and things like that. So the bonding between 4G and 5G will be much more, much smoother. And also what you probably want to do is have your 5G one set to priority 1 and just bond 5G at the same latency. And then you can have the 4G ones bonded and have it hot fail over to the 4G ones. That can be one way that you can make things smooth out better if you're really concerned about that latency difference. But I wouldn't be too concerned about it. You'll be able to create a very reliable connection from doing it bonding between them or individually with a hot failover between them. Okay, so Chris asks, is there any way to automate adjust outbound policy ratios based on speed? Having the load balance better dynamically adjust to changing signals would be great, maybe a future feature. This will be very hard to implement because signal strength does not always correspond or very rarely corresponds with throughput. So that'd be very hard to do. Ultimately, if you're running over Speed Fusion is going to look at things much better and evaluate which one has more capacity to handle the traffic. So Chris again asks, a lot of streaming servers detect and block access via VPN services. It's not actually the VPN service that's blocked, it's the IP addresses. So it's a case of getting IP addresses that aren't blocked and using them for your endpoint, and then you'll be okay. So Daniel asks, will SpeedFusion work on 2 VSAT connections with both latencies similar? No, it won't, because it will work, it'll connect, but the throughput will be really bad. It's to do with the TCP spoofing acceleration. It doesn't allow much throughput. I've tried it with 2 VSAT connections that were 20 meg download each. And each connection, if we test them both individually or even together at the same time from separate computers, we're able to get 20 megabytes throughput at the same time on each connection. Running SpeedFusion across it, we were able to get about 1 or 2 megabytes bonded between the two. It's just that the TCP spoofing doesn't allow it to ramp up to the throughputs that are available there. I'm just going to have a look at the chat because there seems to be a few things going on there as well. So Theos would be good to have a matrix for all models to see a glance at which ones support local SIM injection or fusion SIM. Okay, so all the models that I showed back here, these, which one was it? This one here. So all of the ones here support remote SIM apart from the HD1 dome. So the reason why the HD1 dome doesn't support remote fusion, like over the internet injection, is because it's got only a single cellular modem. It doesn't even have WAN ports. So it means that you're unable to maintain a connection to the internet and to the Fusion SIM cloud while it's obtaining the SIM card. So what it is if you've got the HD2 dome, one of the SIM cards will be active and connected to the internet physically in the dome, and then the second modem will obtain the SIM card over the internet using that first modem. So if you've only got one modem in the device, like the HD1, you can't do it over the internet. Otherwise, all of these devices here are Fusion SIM capable over the internet with the Fusion SIM cloud. Okay, guys, I'm just having a look down some of the comments here as well. So Angus is asking, when will the UBR rugged be available? If you check with your account manager, they will let you know on that. But I believe it was Q3, so that'll be coming up soon, that they should be available. So how does Speed Fusion handle intermittent packet loss and connection link flapping? So this was one of the things that Speed Fusion was built to overcome, was things like that. So Speed Fusion is constantly monitoring all the links for real-time data throughput. And even if a link is flapping on and off every minute or so, Speed Fusion will use it for that time, and then it will drop it off when it is no longer able to pass data. So Speed Fusion is very actively and dynamically analyzing the links for real-time availability and throughput. So it handles it very well. Okay, I've got a few more questions in the questions and answers here. So when using the SIM injector remotely, do you need a permanent connection to the modem for it to work? So you do need, okay, so pretty much the way it works is you have a physical SIM in the router, and then you can acquire SIMs remotely over the internet. And ultimately you can replace all the SIMs in the device with Fusion SIMs that are not even physically in the device. As long as that device remains connected to the internet via one of those SIMs online, Fusion SIM will go on and you'll still be able to use those SIMs. If the device goes offline, you'll lose those SIM cards. You won't be able to use those remote SIMs again, and the device will have to reconnect to the internet using its own physical SIM card or a connection on its WAN. So, and then once it connects to the internet, then it can reacquire those SIM cards from the cloud. So yeah, it does need a connection to the internet for that, and Speed Fusion can help alleviate that if you use Speed Fusion for your connection. Okay, so do we have any more questions there? I know the slide's not frozen, sorry guys. I've just gone back to another slide to just show the thing. So we're just on the questions and answers for now. Okay, cool. Well, I think that is all for today. Cool. Thank you very much to Marcus for helping out with the questions and answers there. And yeah, so we've got our next one. Our next webinar is on Monday, the 18th at the same time. So on that webinar, we will be going across the questions and the long questions. So we're shaking up the exam a bit to the PC exam that everyone would have done in the past. And we are doing a long question there. So yeah, so great. So thank you very much everyone for your time today, and have a great weekend and stay safe. Thank you.